It's actually a very important thing about invariance for principal stress and Deivatoric stress. So actually I actually didn't define invariant for Deivatoric stress if you think about it. So in this video I will just clear some doubts in terms of the principal stresses and also to define your invariance for the Deivatoric stress. So this is the purpose of this video. And therefore to start for the principal stress, if you still remember, the principal stress is just this, right? This one is the solid cube over here with its own stress tensor, right? And this thing is the principal stress itself, sigma 1, 2, 3, and it's something like that. But however, to solve for the values of this, you have to minus with the stress tensor, right? So when you minus, you're taking stress tensor minus away the principal stress, because you're taking this as somewhat lambda, because we are somewhat solving it in terms of like a eigenvalue type of problem, if you remember. So it equals to this thing over here, right? And this is simply matrix operation. Sigma 1 minus sigma is over here. Sigma 1, 2 minus 0 is simply sigma 1, 2 back, type of thing. So therefore, once I get this matrix, I find its determinant. Alright, once I find its determinant and I show you somewhat that it's I1, I2 and I3 is simply these values. Alright, it's simply all these values. In other words, its determinant equation is this equation, while I1, I2 and I3 are being specified over here. Alright, if it don't ring a bell, you should watch back that video. Alright, now what's special is that I actually didn't tell you this page. Alright, I actually didn't show you this page. What's special about this page? This page is the I1, I2, I3, you see, it's in terms of sigma 1, 2 and 3. Alright, for example, sigma I1, for here, I1 is in terms of sigma 1, 1, sigma 2, 2 and sigma 3, 3. What is the difference between them? Therefore, I'll just show you a simple example such that it is easier to convey. We have a 2 by 2 matrix. Alright, this is a stress tensor, which is similarly like this one. Alright, which is like this one. Correct? In terms of sigma 1, 1, sigma 1, 2, like this. Okay? And if we minus away our principal stress, because we want to find this value, right? You can actually somewhat similar to this one, 3 times 3. Correct? What I have is this matrix over here. Alright, 2 minus sigma. So it means this value minus sigma, and then 3 minus 0 is this one. Alright, so this is similarly like this one. Okay, same thing. Okay, and then if I were to find the determinant, then I can straight away solve for the value for sigma. So in the end, what I would have getting the determinant is maybe sigma 1 is equals to 5, sigma 2 is equals to 6, and therefore this matrix will become 5, 6, something like that. You get what I mean? The magic is actually determinant, finding the determinant between this one times this one minus this one times this one. Alright, and then after that I solve for the roots to solve for sigma. Later on we have an example to show more better, but I believe that this example right now conveys what I want to convey. Alright, and therefore let's continue. So after finding the roots, alright, for sigma, I will have sigma 1 equals to 5 and sigma 2 is equals to 6, which is this value over here. Alright, so far so good. This is my principal stress because I already found out its value. Okay, now what about invariance? If I want to find invariance, if I only want to just find invariance, I wouldn't go through all this determinant step, right? This is way too long. If it's 3 times 3 is way too long. Alright, so in order to do that, I can actually find the invariance if let's say I have a stress tensor over here. Alright, which is sigma 1 1, sigma 1 2, sigma 2 1, etc. Right, with these values over here. Alright, now this come back to here already, because we have these equations. Although this is 3 times 3 right now, but it will convey what I want to convey, is because the invariant one, which is this one, alright, the constant for the determinant equation, if you still remember this equation, I hope that this is pretty clear to you. Alright, the I1, alright, is simply sigma 1 1 plus sigma 2 2. Alright, if it's for 2 by 2 matrix, which is this one. Okay, which is this one. So sigma 1 1 and sigma 2 2 add up, you'll give us our I1. So I1 is simply 2 plus 3 is equals to 5. Straightforward. Okay, and then if I want to solve for I2, then it's this equation. Alright, in terms of 2D is this equation minus away this equation. Alright, so it's sigma 1 1 sigma 2 2 minus sigma 1 2 square. Alright, so in that's the case, then 2 sigma 1 1 times sigma 2 2, so 2 times 5 minus sigma 1 2 square. So it's actually this should be 3 also, this should be 3, sorry, because it's a symmetry, so it's 9. Alright, so sigma 1 2 is 3 over here. Sigma 2 1 is also 3 because it's a symmetry matrix. So my values actually over here is wrong, okay? And therefore I will have 1. And my I2 is equals to 1. I don't know my equation is correct or not, but at least you know that when we have this stress tensor, we can straight away find our invariance straight away, very fast, very chop. Okay? But what make it special for the other case is this case. Alright? This case applies when you're talking about if, let's say, you're not given this stress tensor. However, you are given your principal stress. You have this value over here. So if you are given the principal stress already, then you can straight away sub in, just like what we sub in for the previous for this case. Alright, but instead we are actually subbing in the values for the principal stress, because the principal stress is simply sigma 1, this is sigma 2, right? Or in other words, yeah, this is sigma 1, this is sigma 2. I mean this value is 6 lah. Okay, if let's say you refine the roots for sigma 2, we say that is equals to 6. So as you can see that the subscript over here is different from the subscript over at this side. It's sigma 1 1, which is the stress tensor. Now we're talking about principal stress. Principal stress is only about sigma 1 with one initial notation, that's all. So if you want to find I1, then you can straight away get this value plus this value. So sigma 1 plus sigma 2 will give us our I1, which is 11, something like that. But because I anyhow bomb my values over here, alright, so this outcome is different from my I1. Alright, it should be the same. Alright, it should be the same because I anyhow bomb my value for my variables over here, because I solved for the determinant, I didn't solve. If we solve, we should have some values that is correct. Then when you sub it into this equation, we should get the same value for I1. Alright, so in other words, to summarize for this principal stress thing, is that for this case, look at if it's a sigma 1 1 or what. Alright, if it's in terms of sigma 1 1, then you know that you should know some information about the stress tensor. If you have, or in other words, if you are given principal stress and you're asked to find the invariance, then you should use this approach. Alright, in terms of sigma 1 and sigma 2, one initial notation. Alright, I hope this is pretty clear for the principal stress part. Alright, as for the Deivatoric stress, it's the same thing. Alright, but because I didn't go through, I didn't show you that actually Deivatoric has invariance. Alright, so likewise for Deivatoric stress invariance, you have this one over here. This one is your principle of your Deivatoric stress, which is this one. Okay, your Deivatoric stress is actually this one. Alright, meaning this is your stress tensor minus away your hydrostatic stress. You will have this outcome. Alright, and if you want to find the invariant, you have to if you want to find the Deivatoric invariant, alright, then you have to first find the principal stress first. Alright, the principal stress means that you're gonna minus away sigma of like this matrix over here, and then once you do that, and then you find the determinant between this outcome, and you should get something like that. Alright, so normally in other words, for normally in Deivatoric stress, alright, you're actually straight away given the principal stress, because alright, this may sound a bit confusing, but this is Deivatoric stress. This thing is the principle of Deivatoric stress. Alright, so this is totally two different things. Alright, but if you want to find invariance, you have to use the principle of the Deivatoric stress. So far so good. And therefore, normally in tests, I assume that this principal stress of the Deivatoric stress will be given. So you are given in terms of sigma 1, like what we have done earlier. So you are not given a stress tensor. It will be a long chunk of method. So you will be straight away given this values, stating that it is a principle of Deivatoric stress. But I don't think they'll tell straight away, but they will just say that this is a Deivatoric stress function, maybe 5 to 4. Let's say these are the values. Okay, so from there, or maybe I shouldn't say that. We should say that sigma 1 is 5, sigma h is 2, and then this is 2, this is maybe 2, this is 4, this is 3, this is 2, okay. Because hydrostatic stress are all same, so it's all 2. And then sigma 1, sigma 2, and sigma 3 are simply the Deivatoric stress if you were to solve for the determinant. But anyway, so if you have this case, alright, you have all these values already, what you can do is to just straight away sub in to find your invariance. Your invariance is simply all this. So what you're subbing in is in fact the principle of the Deivatoric stress. You're actually subbing in the principle of the Deivatoric stress. So you just sub in sigma 1, sigma 2, and sigma 3. Alright, you don't sub in sigma 1, 1. Alright, you don't sub in sigma 1, 1. This is from the stress tensor. We are actually using the values from the principle of the Deivatoric stress. Alright, so this is the conceptual understandings that I would like to convey in this video. And I hope that it will be clear for you. And I shall see you in the next video.